Good morning, everyone. My name is Hemu, and I am from the Skilled Inspirational Academy, which is CNET. And we have just invited all of you for the Palo Alto Firewall demo. So generally, demo is around somewhere around 90 minutes. Okay. So that demo generally I have to start from 11 a.m. IST, but I think we are around 15 minutes late today. Those are the contact numbers. So during, if you have any query, if you are interested to join this training, this is my direct number. You can reach out to me if in case of any issues. This is Bidit's number. You can reach out to him as well. And we have a Mushkan. So you can also reach out to Muskan ma'am on this number. So those are the three contact numbers. Now let me tell you regarding this particular batch. So guys, we are starting one batch on Palo Alto Firewall. Once Palo Alto Firewall we will complete, we will start your F5 load balancer, which is your F5 LTM. So it's a combo batch, and that batch I will start from the 8th of November. Timing is 9 a.m. to 1 p.m. IST, and it's a weekends batch actually. It's a weekends batch. Your classes will happen Saturday and Sunday. Fees for this particular training is 12,000 INR for Indian students, 150 USD for international students. Now, you do not have permit. Okay, live stream I cannot able to do right now. Okay, not an issue. Okay. So let me tell you agenda of today's session actually. So guys, in this particular training, what I am going to cover, let me just tell you. And here I will go with the Palo Alto perspective. So Palo Alto firewall training is around 54 plus hours of training. You will get the lifetime interview support. You will get the documents. You will get the access of recordings of each class with lifetime access through our learning portal. I'll help you building the lab in your laptop. And if your laptop is not sufficient, it is not having sufficient resources, then the same lab we can build over the Google Cloud. It's a weekends batch, so your classes will run on Saturday and Sunday. During the batch, you can able to discuss any issues if you are facing in your production environment, and also if you are facing any issue in your lab environment, like when you are doing the labs, you can able to discuss those type of issues. You will get the support for mock interview as well if required. So this is what I am going to cover in this particular training. Now, let me run through the course content. What are the topics I'm going to cover in this particular training? So I'll go through with the course content, and also I will tell you one topic, which is your life of a packet in Palo Alto Firewall or Palo Alto Firewall packet flow. So I'll give you the basic understanding of this packet flow because it's a very big class. I will run through couple of sorry. So I will run through couple of basically slides here, and we will basically discuss the advanced level packet flow according to the latest PAN-OS version. Okay, so this is the flow diagram. I will use this flow diagram to cover your packet flow. So entire thing will be discussed, but not in too much in depth because packet flow is generally a 3 hours of session. But here I will give you the basic understanding of packet flow. Okay, now let me just go through with the course content. Sorry guys, actually I was sick actually, so I'm still recovering. So that's why you will see I just suffered with cold. Okay. So guys, generally when I used to teach Palo Alto Firewall, I used to start with the very basics. where I will cover like what is Palo Alto Firewall, or like what is firewall, what is stateful inspection. Or I will cover all those things. Like I will go through with the platform and architecture, where we will discuss the Palo Alto Firewall platforms. What are the hardware models offered by the Palo Alto? What are the virtual models offered by the Palo Alto, right? What are the models which is offered by the Palo Alto for the cloud native devices and all, right? So all those things I'll cover in the platform section. And I will discuss the architecture as well. Like what is SP3 architecture? What is single pass software and parallel processing architecture of Palo Alto? Because in every interview, they will ask this particular question. What is the architecture of your Palo Alto devices, right? So that architecture I will discuss, and also I will cover the data path here. Data path means, if you will see here in this diagram, this is the data path actually. This is the data path of Palo Alto Firewall 5200 series boxes, which is generally used at the data center level. So in this particular data path, I will go through with the hardware component. What is the use of Qumran chip? What is the use of FE100 chip or the network processor? What is the use of Octeon chip or the data plane 0, DP0 CPU, DP1 CPU, DP2 CPU, right? Then what is the use of CE100 chip? Or this is a signature match processor, right? What are the use of all those processors? How packet basically travel from one hardware component to another hardware component. I will also give you the idea of the data path, like in the first generation boxes. Like if you heard the name of PA 5000 series will be there, 3000 series was there, 2000 series was there, right? Those are the first generation boxes, right? Then they used to have a Marvel or Petra chip. They used to have a Liger or Tiger chip as a network processor. Then they have a Octeon chip as a data plane CPU, and the Ocelot or the Jaguar chip at the signature match processor, right? So all those things I will cover in your architecture generally. And now once this part will complete, I will move towards your. So once your SP3 architecture is completed, then after that, I'll just move towards the flow logic or the packet flow or the life of a packet in your Palo Alto 5, because this is also important. If you know the packet flow, you can able to know if you have done some, let's suppose you have done some configuration now, you at least you have to know where the security policy match happens, where the net lookup happens, where the app ID comes in a picture, right? At what point of time your packet go inside the content engine, right? At what point of time your packet go inside the SSL engine, right? All those components you have to know, then only you will able to at least do the troubleshooting. So I will discuss each and every component of flow logic or packet flow. Once that part is completed, I used to move towards the initial configuration. Initial configuration, how we can do the initial setup in your Palo Alto firewall, how you can access the Palo Alto firewall to perform the initial access. What are the ways to do the configuration in Palo Alto? So mostly, if you know guys, with regards to the initial configuration, if you know, we have to do the configuration of host name, which is mandatory, right? We will do the configuration of domain name, host name, domain name, NTP, DNS, SN, SNM, SM, sorry, SMTP, SNMP, right? All those configuration we have to do. Like your LDAP profile configuration, all those things we have to do. Admin accounts, right? Proxy settings, all those things comes under the initial configuration, and we will cover all those initial configuration. If I have a firewall, let me just show you. So in initial configuration, generally, the most of the part is you go to into setup. Most of the things we have to do in the general settings, like your host name, domain name, login banner, SSL profile, time zone, language, right? Language, all those things. Then services, here we have to configure the DNS settings, NTP settings. If proxy is required, then we can configure the proxy settings as well, right? Management interface IP address, netmask, default gateway management services. We can restrict the management access by defining some permitted IPs here, right? So all those are the things which comes under your, and also one more thing like SNMP setup here. SNMP setup is also part of initial configuration only. And once your initial configuration is done, once your firewall is accessible via the GUI or via the CLI, and after that, what we have to do? After that, we have to basically cover your license. How we can activate the licenses? What are those licenses, right? So all those things I will generally cover in the initial access. Tell me one thing, guys. How we can basically get the access of firewall? What are the ways? We can access via the web UI, right? We can access via the SSH, we can do the console, right? And also we can access via the API. Those are the 4 ways available mostly, right? So then all those ways I will cover how we can do all those type of configuration in the initial access. Then the configuration management, most important part. How you can take the backup, how you can export the backup. If you did some misconfiguration, then how you can roll back those things, right? All those things comes under the configuration management. So I will cover everything. What I'll do, I'll cover everything. License and software updates, right? How we can do the licensing, how we can manage the software updates. Because Palo Alto offers some cloud based services like Wildfire. It also offers the services like threat prevention, vulnerability protection, right? Your IPS functionality, anti-spyware protection, anti-virus protection, right? All those comes under the cloud services, right? And for that we have to do the dynamic updates. Also we can manage the software updates, how we can basically manage the pan OS updates, how we can upgrade the firewall, how we can downgrade the firewalls. All those tasks I will cover here into the licensing and software updates. Then your account administrations, how we can add the account for L1 engineers, for L2 engineers, for L3 engineers, right? All those things I will cover into the account administration. How we can use the Radius server to basically manage those engineers profile which are available in your ICE server or maybe the Aruba ClearPass servers using the Radius protocol. Then I will go through with the admin roles. How we can create a different roles for different network administrators. Like L1 engineers, what type of access we want to provide. What level of access we want to provide, like mostly like those like AAA services. So we have a admin roles. Once that part will complete, I'll move towards your interface configuration. How we can do the interface configuration, how we can create a security zones in your Palo Alto firewall. What is the concept of security zones in your Palo Alto firewall? What is layer 2 deployment? What is layer 3 deployment? What is virtual wire deployment? What is tap mode deployment? I will run through all those deployments and we have a dedicated labs for that. I will go through with the concept of sub interfaces, and also I will go through with the aggregate interface concept. And all those labs basically I will do in the VM devices and also in the hardware devices. So I do have a PA 440 hardware box. So I will use that box to perform some of the hardware based labs as well. I will cover your DSCP. How we can use Palo Alto Firewall as a DSCP client, as a DSCP server, and as a DSCP relay agent. What is the concept of virtual routers? How we can create a multiple VR setup, and what is the use case of multi VR? Like one virtual router for LAN and DMG subnets, and one virtual router for WAN subnet. We at the WAN side maybe we are running BGP. At the LAN side maybe we are running OSPF. Then how we can allow the communication between both the virtual routers, right? So in your Palo Alto Firewall to run the routing, to manage the routing, we have a concept of virtual routers. So we will cover those. Once that is done, I'll go through with the security policies, how we can create a security rules, how we can create a net rules, how we can make that security policy configuration, net rule configuration, how we can do the policy administration, how we can configure different net types like source net, destination net, and there is a there are total of 4 use cases of your destination net. I'll cover all those destination net. I'll cover your static net, how we can configure the static net, how we can configure the U-turn net, right? So generally I will cover everything in your net. So generally those security policies and net, I used to take 3 classes for that dedicatedly. Then I'll cover the app id. I'll go through with the advanced level app ID concept. Like I'll go through with the app ID overview. What is application groups? What is application filters, right? And we will do multiple practicals here. Like I'll blog the YouTube. In Facebook, I will block the Facebook chat, and Facebook uploading in other Facebook application will work, right? So those type of labs we will do. We will also create some custom app. Let's suppose you have some internal application, then I'll go through how we can create a custom app. We will discuss the app override, right? So if you don't know those things, let me just give you some idea. Let me restore all my tabs. You will get some idea here. And don't worry about the GUI. I will cover everything with regards to GUI. Okay. So, if you will go into this objects tab, we have different app ID database here, right? And if you will see here I have created couple of custom apps. Those are the custom apps, right? So I will create the same type of custom apps. Okay, then we will use those custom apps to create different type of policies. See, multiple policies are there. I have blocked some of the rules, some of the apps, I have allowed some of the apps, right? So everything will be covered in detail. Then once app ID will complete, I'll move towards the content ID. In content ID, we have a antivirus protection, anti-spyware protection, vulnerability protection. Those 3 features basically facilitate the IPS functionalities. We will discuss in detail, and even though guys, I will try to download the live malicious files. So what I'll do, because I am from the cybersecurity background, so I know how we can create a malicious payloads. Okay, those malicious payload I will try to download. I already have created in my Kali Linux machine, and I also explain you how you can create. That's not a big deal. And those malicious file we will try to download, and we will see how my firewall is protecting from those type of malwares. Then we will discuss the URL filtering. Most important, like how we can block the traffic on the basis of URLs, on the basis of URI. I'll go with the external dynamic list configuration, EDL configuration. I'll go through with the custom URL categories, like multiple practicals we will do with regards to URL filtering. If I'll go again on my firewall here, and even though I'll tell you the best practice, how you can create, like if I'll go into the antivirus, how you can create a alert only AB, outbound AB, inbound AB, internal AB, right? How you can create those particular things. I'll give you the both CLI template and the GUI template, so you can able to configure. Then how we can apply all of them just from here by creating the security group. And URL filtering, you can see I have a 2 URL filtering profiles. Custom URLs we will do here. See, those are the website where I have on my allow list. Those are the website which I have on the block list, right? So those type of things we will do actually. It's not like that. If I'll go into the monitor tab where we see in the URL filtering, I have done multiple practicals on my last batch. See, multiple practicals are there similar to with your antivirus, anti-spam vulnerability. See, those are the malicious file which is created by myself. Okay, and if somebody try to download those files, my Palo Alto Firewall will protect us. Okay, so those type of practicals we will perform. Once that part will complete, I'll move towards the one of the most important feature, which is your Wildfire. How we can basically do the configuration of Wildfire and the file policies. How we can allow the downloading of the files, uploading of the files, different practicals we will do in your Wildfire and the file block policies. Then security profiles, file, sorry, security profiles, file blocking, all those things. Okay. Now, see, tell me one thing, guys. Your content ID features, including your antivirus protection profile, anti-spyware protection profile, vulnerability protection profile, your file policies, right? Wildfire, all those, or your URL filtering as well. All those features, they works on the basis of your layer 7 content from the IP header. But about the, if somebody is trying to launch the attack on the basis of layer 3 and layer 4 information, like using your IP header fields, using your TCP header fields or the UDP header fields, right? For that, we have a zone protection and dose protection. Like let's suppose somebody has launched the ICMP flood attack or TCP flood attack, UDP flood attack, or let's suppose somebody has launched the IP spoofing attack. How you can protect from all those type of attacks? For that, we have a feature called zone protection and DOS protection. And I will basically run through with all those attacks. I will generally I used to have a Kali Linux machine, and from that machine only I used to run all those type of attacks. And you will see those attacks are going and are my Palo Alto firewall blocking from those type of attacks. Tell me one thing. If you know the TCP, in TCP we have a flags, right? If you remember, we have a SYN flag, right? Do you think SYN flag equals to 1 and FIN flag equals to 1? We can set on the same packet or same segment or same TCP header. Is this combination possible? It is not possible. If somebody is sending those type of packets, then how we can prevent from those type of packets, right? Tell me one thing, at the IP header, at the IP, at the layer 3 header, let's suppose your source IP equals to 10.1.1.100 and your destination IP equals to is also 10.1.1.100. Is this type of packet is possible? Where source and destination both are equal? Right, then how, if we are receiving those type of packets, then how we can basically protect us from those type of packets? How my Palo Alto firewall deal with those type of packets? For those only, basically we have a zone protection and DOS protection profiles. Okay, then now nowadays most of the websites, they are the SSL based, yes or no? Most of the websites are the SSL based, right? Let's suppose you have connected your laptop with one of the SSL based website. Now, when you will connect your PC with one of the website which is hosted here, there is a one SSL tunnel is created. Now, whatever information you will exchange inside this tunnel, it's all encrypted. No one able to see that information, right? Now, let's suppose if this particular server has some malware. Now, if that malware is trying to is going through this SSL tunnel and it will get installed in your system. Let's say we have a firewall here. Then do you think my firewall can able to protect? No, it will not able to protect. Why? Because your data is encrypted. It will not able to read the encrypted data. So for that, what we have to configure the decryption or SSL decryption in your firewall. And once you will enable the SSL decryption, my firewall able to protect. So you know those SSL decryption concept we will cover, certificate management we will cover, right? I'll go through what is the root CA, what is intermediate root CA, then what is the end user certificate, right? All those hierarchy I will go through. I'll go through with the SSL handshake. I will explain what is client hello, what is server hello, what is certificate change, what is client key exchange, right? All those things we will discuss in detail. It's not like that. Those concepts I used to cover very in depth. Then outbound SSL decryption, inbound SSL decryption, how we can configure those inbound and outbound SSL decryption, and also SSH decryption. Mostly, guys, nowadays, most of the people they used to bypass their firewall using the SSH tunnel. And if somebody is doing this, how we can able to basically enable the SSH decryption as well? So we will do those type of practicals. Then user ID, most important feature of Palo Alto Firewall. How we can configure the user-based policies in your Palo Alto Firewall. Because nowadays, IP address is not fixed. Because people are getting the IP address via DSCP. So most of the organization, they need a user-based policies or user ID-based policies. I'll go through with the Active Directory integration. Users to IP mapping. How we can achieve users to IP mapping using the built-in PAN-OS user ID agent and also the external user ID agent. And here I will also explain you how you can build the Windows Server 2016. How you can basically create a DNS servers over there, certificate CA services over there, and your user services over there, right? Everything I'll cover. Then we will create a LDAP profile and we will integrate that particular server in your Palo Alto firewall to achieve the users to IP mapping and also users to group mapping. Once those mappings will created, we will utilize now those mappings in our security rules. We will create authentication profiles, and those authentication profile we can use to authenticate users as a network admin. We can use those authentication profiles in our global protect. In our global protect, right? So same database I will utilize there. Once that particular topic will complete, I'll move towards the IPsec site-to-site VPN. In IPsec site-to-site VPN, I will go through with the advanced level explanation on phase 1 and phase 2 exchange, IPsec tunnels, and the 13 use cases of your IPsec VPN. Those are the 13 practicals of your IPsec site-to-site VPN. Apart from this, I will also go through with the how we can read the IKE Manager daemon log file. And using this particular IKE Manager daemon, I will try to take out the keys. And we will basically decrypt. We will basically decrypt the IPsec traffic. See, if you know the IPsec VPN, your packet number 5 onwards, 5 and 5 onwards, till 9, all your data is encrypted from the control connection point of view. And after that, whatever the data will exchange through the IPsec net, it is also encrypted. Then I will tell you how we can get this particular key and also this particular key. And for doing those particular labs, I generally uses this particular lab. Head office, branch office 1, branch office 2, and the customer firewall, which is Cisco ASA. And we will try to do all the labs here, all the practicals here, all the use cases we will test into this particular environment. So IPsec, everything we will discuss, like how we can create IPsec VPN using the pre-shared key when both peers have the static IP, how we can create IPsec VPN between the two Palo Alto Firewall having a static IP, but this time we will use the certificate for the authentication. Then how we can create IPsec VPN if we have a overlapping subnets. How we can create IPsec VPN when one peer have the IP address via DSCP. How we can create IPsec VPN between two Palo Alto devices where one device is behind the NAT gateway. Then we have a dual IPsec site-to-site VPN with dual ISP from single firewall with a remote firewall using the failover using tunnel monitoring, failover using static path monitoring, and failover using the virtual router and PBFs. All those use cases we will cover. Sorry, 1 minute. Then between your Palo to ASA, Palo to ASA when PA have a dynamic IP. Route-based VPN we will cover like route-based IPsec using OSPF. And hub and spoke VPN, we can configure the OSP for BGP and we can basically achieve this hub and spoke kind of setup as well. So those are the 13 use cases. Once that part will complete, I'll move towards the GlobalProtect. In-depth information I'll cover with the GlobalProtect. I'll go through with the GlobalProtect connection flow, GlobalProtect connection methods, user logon, on demand, pre-logon, then on demand, pre-logon, then user logon. All those methods we will go through. See, the most important part in GlobalProtect is the connection flow. If you know the connection flow, you can able to do the troubleshooting. In GlobalProtect, I will also tell you what is the use of REST manager daemon. There is a one process called REST MGR who will maintain the backend logic of your GlobalProtect. What is the use of Nginx daemon in the GlobalProtect, right? What is the use of SSL MGR, SSL manager daemon? All those particular daemons with debugs and everything we will cover. I'll tell you the commands, how you can run those debugs and all. Then your active passive high availability, configuration of active passive high availability, active high availability, configuration of active HA, floating IP HA lab we will do, ARP load share lab we will do, mixed mode HA lab we will do, and also here I will cover the advanced level architecture of HA. Advanced level architecture of HA. What is the use of HA agent daemon? What is the use of system daemon, SysD? What is the use of pan DHA daemon, right? How your HA1 do the communication with HA2, how they will create a TCP connection, how they will create a raw connection, right? All those things we will cover in HA. On that part will complete, I'll go at the end, I will go through with the packet filter, packet captures, flow basic, TCP dump commands. So those are the topics which I am going to cover in this particular training. And generally, if I'll tell you something, I'll come here again. So if I will tell you here, let me give you one example how I used to deliver the content. So let me just look for the HA. So HA, where is this HA lab? This is the one. So generally I used to take the help of some diagrams, and I used to create some diagrams like this. So if you will see, so like that, I will try to refer, and I used to explain the concept like in HA. Those are the things I will use. I will create the document diagrams here, right? So multiple things we will do. HA types. Then this is the advanced level architecture I will cover. So some of the those diagrams I have already created because they will take some time, right? So like that we will discuss. We will do lots of troubleshooting, and also I will not only go through with the configuration of those concept by a CLI. I will cover GUI and CLI both. So I used to focus more on the GUI as well, more on the CLI as well. Okay, now, so guys, to complete the entire Palo Alto training, whatever topics I have mentioned in this content, it will take around 9 to 10 weekends. So there are total 19 to 20 classes, each class of 4 hours. There is a gap between the class, around 15 minutes of gap I used to give. Otherwise, your class will go strictly at 4 hours because content is huge, and mostly I used to perform around 75% labs. You will get the CLI templates, how you can create a CL templates and all. And also I used to share this user manual, which will help you to prepare for the interview. Everything will be there, all the concept will be there, theoretical stuff will be there. So you can able to refer and you will get the everything. Commands will be there. So all those things will be available through this. Like those are the day one. So I used to mention those topics and I used to start like this. Okay. So training will be very smooth. You will understand all the concept. I take the help of those images to basically cover the concepts properly. Okay. Okay. Now, now guys, let me just run through the Palo Alto Firewall packet flow. Not in depth as I mentioned. I'll go. So before explaining the packet flow, so guys, if you will see this particular diagram, let me not in visible properly. So if you will see this particular diagram, this is the old Palo Alto Fire Packet Pro, and I think it is released by the Palo Alto Firewall in 2010, and we are in 2025. There are so many updates happens, and nobody has released a new packet flow diagram. Still, people are referring this only, which has lots of missing information, right? Like in this diagram, if you will see, they have only mentioned few things like packet at the ingress stage, some of the part is missing here. Then your fast path, slow path, app ID, content ID, and the forwarding. But in you can see in slow path or firewall session status only forwarding lookup, NAT policy lookup, firewall security policy lookup, that's it. The forwarding, right? But if I'll just give you the idea of this slow path, see here and look into mine. Let me just go into only the slow path. See, zone protection, they have added IP user and user group cache, they have added application cache, they have added then forwarding lookup, then net policy lookup, then they have added authentication policies, the DOS policies, then security policy match, right? And after that they have added some TCI policies as well, right? So multiple changes they have done. So all those changes I have basically covered on this one. So I will discuss the latest one. Okay. Now, so before starting the packet flow, let me just run through one very important thing, which is the data path. Okay, I hope guys my diagram is visible properly. Yes, demo recording is going on. Just confirm on the chat if, if it's visible properly. Yep. So guys, this is a PA5200 series firewall data paths, right? In PA5200 series boxes, we have a interface module here. So which includes your copper interfaces and the fiber interfaces. All your copper interface or fiber interface module, it has a direct connectivity with one of the chip called Qumran chip. This is the chip who will basically holds or maintain or manage the port whenever we will connect the copper interfaces or the fiber interfaces. So all those things got connected with the Qumran chip. This Qumran chip has a direct connectivity via the links called joy links. Those are the high speed fiber links. Okay, those are the internal links only, and it has a connectivity with one of the processor called network processor. And the chip name for this network processor is FE100. This is a FPGA or field programmable gateway array or the ASIC. And this network processor generally acts as a session offloader. Means this is the chip who will only handles the session which is offloaded by your data plane. What is offloaded by the data plane CPU or the Octeon chip. Okay, which is offloaded by the Octeon chip. And guys, this network processor is only have a capability to do the packet processing on the basis of layer 2 and on the basis of layer 3 information. Layer 2, layer 3 information it can able to read, and it is able to perform those things. Okay, now once after that, once your packet reached into this processor, it will go into the Octeon chip here. Octeon chip is a chip where your packet flow applies. Packet processing will start generally from the Octeon chip onwards. This is a chip who can understand the layer 2, layer 3, layer 4 information, and also guys it can understand the layer 4 information. Okay, so layer 2, layer 3 and layer 4 information it can understand. It can do the packet processing. Ingress stays, your flow lookup, which is your session table management done by the Octeon chip, your session setup or the slow part done by the Octeon chip, your fast part task done by the Octeon chip. Okay, then why we have this signature match procedure? Signature match procedure, this is again a FPGA, and here we have a chip called CE100. This FPGA is responsible for two tasks. All your application identification done by the signature match procedure, and your content ID task like your antivirus protection, anti-spyware protection, vulnerability protection, your file blocking, everything done by the signature match procedure, because it can able to read the layer 7 data. layer 7 data it can able to read. The algorithms which runs on top of this chip is, first algorithm is your DFA, AHO. There is a one more algorithm nowadays running which is PScan. Those are the algorithm runs on top of this particular processor, and who those algorithm is responsible for app ID and content ID related task. Voice less, kindly increase the volume. Guys, my voice is not coming properly. Write on the chat. Generally, I was at the high volume only. Can somebody confirm? It's clear, right? Okay. There is a one message I have received from one of the guy. Okay, great. Okay, now. So guys, see, it's not, there's a huge things we have to discuss here as well, but I am just stopping my discussion at the data path here. Okay. So just remember, your packet processing will be done by this particular processor Octane chip, and your layer 7 task here like app ID and content ID done by signature match processor. Whatever, now this network processor is only process the packet which is offloaded by this particular processor which is DP-CPU. If some task he has, generally this chip, it will assign some task to network processor, and those tasks only it will perform. And now guys, see, let me tell you one more thing. See, if you are basically dealing with, let's suppose 820, 850 series, okay, or 30 to 20 series, or 3410 series, or 1400 series boxes, or 400 series boxes. Those boxes, they don't have that type of architecture. That architecture is basically available in the high-end boxes like PA50 200 series box, 5400 series box, 7000 series boxes. Okay. Now, if those particular, they don't have that type of architecture, generally those devices, they don't have network processor. They don't have signature match processor. They only have single Octane chip, and that chip, your network module will also connect it directly with this chip, because this chip is capable of doing all the tasks. Then app ID and content ID, that time your DFA and AHO algorithm runs on top of this chip, because those are the low end boxes. Low end box, they just have a single CPU, which is the Octane chip. Okay. So this is the architecture for high end boxes. Now, before that, let me also tell you one more thing, guys. See, in this particular diagram, if I'll go here a bit, so generally when any PC initiates a traffic towards the firewall, let's suppose we have a server hosted on TCP port 80, right? So it's a communication between PC and server. So you know guys, it's a TCP. In case of TCP, what is the first packet? Always a TCP send, following with TCP send plus ACK packet, and after the acknowledgement. Those are the three packets they used to exchange. Now, when your first packet received by the firewall, what it will do, it will start processing this packet according to the stages. Your ingress stage, your flow lookup, your slow path, your fast path, your app ID, your content ID, and the last stage is egress stage. So those are the 7 packet processing stages: ingress stage, flow lookup, slow path, fast path, app ID, content ID, and ingress stage. Also, let me tell you one more thing, guys. See, when we will receive a TCP send packet, because TCP send packet, it has a 0 layer 7 data. Layer 7 payload is 0 in TCP SYN, TCP SYN plus ACK, and the TCP ACK packet. So you know those packets, they will not go inside the app engine and content engine because there is no layer 7. When you have a layer 7 data, then only your packet used to go for app identification and the content identification. Just remember. Why? Because this particular those tasks done by the different engine, which is your signature match procession. Okay. So now let me just give you the idea how generally packet is handled by the Palo Alto Firewall. So you know guys, when we receive a packet, let's suppose this is my PC having IP address 10.1.1.70. This is my firewall. This is Ethernet 1x2 interface. This is Ethernet 1x1 interface. And here I have a server. It is hosting the service on TC port 80, let's suppose. Okay. This is my inside interface. This is the DMZ1. Okay. Here I have, let's say, IP address 10.1.1.250/24, and here I have IP address 10.2.2.250. Okay. Now, when this PC initiate a packet, he will send the first packet. When this packet received by the firewall on Ethernet 1x2, what it will do after receiving this packet on the Ethernet 1x2 interface, what it will do? My firewall put this packet into the ingress packet processing. It will put into the ingress stage. In ingress stage, what are the tasks it will perform? In the ingress stage, the very first task it will do, it will extract the layer 2 information, layer 3 information, and layer 4 information from the packet. What do you mean by the layer 2 information? So I'm putting the main information, source MAC, destination MAC, 802.1q tag. I'm just putting the main information and also the ether type. This is the main information it will extract from the layer 2 header or from the layer 2 frame. From the layer 3 header, my firewall going to extract the source IP address, destination IP address, and layer 3 protocol number. What is the source IP here? 10.1.1.70. Destination IP 10.2.2.101. Let's say it has a 10.2.2.101 IP. Layer 3 protocol number. What is the layer 3 protocol number for TCP? It's 6. It will extract the layer 3. And from the layer 4, it will extract the source port. Generally, source port is random. Let's say 3050. Destination port. Destination port is 80. It will extract those information, layer 2, layer 3, and layer 4 information from the packet. Once it will extract that information, what it will do? It will start doing the ingress interface or the source zone lookup. Now, tell me one thing, guys. This packet I have received on which interface? Ethernet 1x2 interface, yes or no? Now, this Ethernet 1x2 interface is a part of which zone? It's a part of inside zone. So, you know, I got the zone details which is inside. This is the source zone. Now I have a source zone details. So, you know, at this particular stage, it will only perform those tasks. It will try to get the source zone. Okay. And also it has the entire information from layer 2 header, entire information from layer 3 header, and entire information from layer 4 header. Now what it will check? Now it will check the same packet for ingress errors. What do you mean by the ingress error? Tell me one thing, guys. What is the minimum size of TCP header? 20 bytes. Minimum size of IP header is also 20 bytes and maximum size is 60 bytes. Yes or no? Let's suppose the size of your TCP header is 18 bytes. Or maybe your size of the TCP or IP header is 68 bytes or 70 bytes. Do you think it is according to the TCP IP model? It is violating the TCP IP model, yes or no? If it's violating the TCP IP model, then what will happen? Guys, tell me one thing. How our TCP IP stack is developed? TCP IP stack is developed, right? According to some standard, some principles, and everybody needs to follow those principles, right? So, if there is any type of violation in the headers, tell me one thing, guys. In TCP header, how many flags we have? 7 or 8? Vamsi, how many we have? Let's say, do you think in TCP header if somebody has added 13 flags, it's a it's a correct combination? Yes, you are right, Avinash. It's 9. So we have a 9 flags. There is a one reserve, and they have added ECN bits, ECN and CWR. Those are the extra they have added. Let's say 13 flags somebody has added in the TCP header. It is a correct combination. Tell me one thing. Do you think we can have a port feed in the source port? Do you think we can put this number? 1,28,000. What is the maximum source port range? 0 to 65535. So here it will check those violations. It will check those type of header violations. If there is any violation, then what it will do? It will discard that packet right away. If there is no violation now, what it will check? It will check the DOS block table. What it will check? It will check the DOS block table. If your IPs, source IP or both IPs, have an entry in the DOS block table, which means it's a suspicious traffic and it will drop that packet right away, means discard this packet right away. If DOS block table is okay, now it will go for the firewall inspection. I'm not sure why this is not visible properly. 1 minute, guys. Yeah, I think I have to explain from here. Why? I guess I'm not sure why this information is not visible properly here, right? So see, if your packet is not part of DOS block table, then it will go here. Is firewall inspection applicable? If yes, now it will check. Is your traffic belongs to IPsec VPN or SSH or SSL VPN, which is GlobalProtect, or the GRE tunnel? If yes, then your packet again go for the encapsulation. Generally, what used to happen in case of IPsec traffic, guys, the actual layer 3 header or layer 4 header and the data layer 7 payload is encapsulated inside the ESP protocol, yes or no? In case of SSL VPN, your layer 7 data is encapsulated by the TLS protocol, transport layer security. In case of GRE, your packet is encapsulated by the GRE. Those encapsulation it will remove, and now it will again do the packet processing. Ingress packet processing again it will start, but this time it will start from layer 3 onwards. It will start at layer 3 and layer 4 only, no layer 2. Just remember those are the small points, and in the if you will go for any tech interviews, they will basically check the knowledge here only. Once this is done, now your packet reach here. Firewall flow lookup match. Now it will try to do the lookup into the firewall flow table or the into the session table. In which table now it is trying to do the lookup into the flow table. Then how it will perform that lookup into the flow table? So let me tell you guys, when your packet received at ingress stage, if you remember, at ingress stage it has extracted your source IP address 10.1.1.70, destination IP address 10.2.2.101, source port 3050, destination port 80, layer 3 protocol number 6 for TCP, and your source zone inside. Those are the information which we have already collected in your ingress packet processing stage. Now what it will do now when I reach here into the flow lookup stage or the session table lookup stage, what Palo Alto Firewall used to do, it used to basically take this particular 6 tuple. Those are the 6 tuple information. This is the 6 tuple information of session table. It will run the MD5 hash. It will run the MD5 hash on those values. And what it will get? Some hash value. Let's suppose this is the hash value it has get. Now this hash value is known as flow key. Now what it will do? Now firewall flow lookup match happens. Now what it used to do? Once it will get this particular hash value, now using this hash value, it will do the lookup into the session table. What is session table, guys? Tell me one thing. To store the information in the devices, what we will use? To store the information in the proper format, what we will use? Let's take a very simple example. Let's suppose you have created an account in Amazon.com or in Facebook.com, where your Facebook or Amazon used to store your username and password. In databases, right? So similar to those databases, in Palo Alto, we have a database called MongoDB database. It used the MongoDB database. Inside this MongoDB database, it used to store the session information in a flow key format. In this flow key format, in hashed format, what information it used to has? Your source IP, destination IP, source port, destination port, protocol, and inside zone details. So now it will do the lookup using this particular flow key into the session table, or basically it will do the lookup into the MongoDB database. Now tell me one thing. This is a very fast packet. Do you think we have a session for first packet in the session table? No, there is no session, right? And if there is no session, then your packet go into the slow path. If let's suppose the received packet is not a first packet. Let's say it's a packet number 5. Then your packet go inside. When we will do the lookup into the flow table, what it will do? It will found the session and your packet go inside the fast path. If flow in the session table, then it used to go in a stage called fast path stage. See here for fast path processing. But right, it's a first packet, so there is no flow, there is no session into the session table. So your packet go into the slow path here into the slow path now. In slow path, what it will do? It will basically check the zone protection profile. What is the first check it used to do? It will do the zone protection profile check. Generally, we used to configure the zone protection profile to protect us from the layer 3 attacks or layer 4 attacks. Okay. It will check the zone protection profile, and if it will found any anomaly or errors, then it will basically discard that particular packet right away. It will discard the packet right away. If no, and also it will do the lookup for the TCP state check. What do you mean the TCP state check? Tell me one thing, guys. In the TCP connection, your first packet is always a TCP SYN packet, yes or no? In the first packet is a TCP SYN because only SYN flag SYN flag is set to 1. Do you think, let's suppose we have received a first packet where SYN flag is 1 and also ACK is 1. Do you think this combination is a correct combination for TCP SYN packet? Or let's suppose when equals to 1 or reset equals to 1. It is not a correct combination. How we will check? Because in slow path, only the first packet will go. So it will check the TCP state here, state of the connection. Okay. To protect us from some type of attacks. Okay. So it will check if it will found any anomaly here or anything any problem here, it will discard this packet right away. Now it will go and now it will here it will check IP user or user group cache, means it will enforce the IP to user mapping and users to group mapping. If ingress zone has the user ID enabled, means in ingress zone we have to enable the user ID. If user ID is enabled, then only this particular check enforced by the firewall. It will do the lookup into the application cache check. Identify application if matched with destination IP, destination port, and layer 3 protocol number. So it will use those 3 values to do the lookup into the app ID cache. This is a application optimization feature. Okay. We will discuss more about this feature. There is some commands we can remove, we can add, multiple things are there. Now your packet go for the routing lookup, route table. So guys, in Palo Alto Firewall, we have a 2 type of routing database. We have a RIP database, routing information base, and we have a FIB database, forwarding information base. Your Palo Alto Firewall used to do the lookup into the FIB database, forwarding information base. Forwarding lookup to get the egress interface and egress zone details. Why we have we why we are going to perform the forwarding lookup to get the egress interface or then the egress zone. Because see, we have received a packet. Now we have to egress out this packet from some of the interface, right? And that interface we have to identify by doing the FIB lookup, forwarding lookup. If there is no route, then it will discard the packet right away. One more thing here, guys, just remember, see, if you will configure the policy based forwarding PVF rule, and you have a PVF rule and you have a FIB or forwarding information based FIB table, and you know if PVF, according to your PVF destination egress interface is, let's suppose, Ethernet 1 by 10, and your routing table says Ethernet egress interface is Ethernet 1 by 8, then your PVF rule will take high preference. PVF or PVR, policy based routing or policy based forwarding, will take high preference. Okay. Policy based routing PVF skip the TCI packets, forwarding information base. See, and for layer 2, it will do the lookup into the FDB database. Layer 2 I'm not discussing here. Once this is done, now your NAT policy evaluation will start. It will not perform any lookup here. It will just do the NAT policy evaluation. And if your packet is matching the destination NAT rule, if yes, then again it will do the forwarding lookup. If it is matching the destination NAT rule, then it will use to go again for the forwarding lookup. In case of destination NAT only, because see, when we have done the lookup into the forwarding table, we have done the lookup on the basis of destination IP, right? And if my traffic is matching the destination NAT rule, then my destination will change. If my destination will change, then I have to do the lookup again into the routing table or the FIB table to get the egress interface and zone details for the new IP address. Okay. Once destination is done, now it will enforce the authentication policies. So when we used to configure the captive portal and all, it will authenticate the policies. So it's not like in captive portal, I'll cover captive portal. I will also explain you how we can read the log of L3 SBC process, because there is an issue with the captive portal. This is the daemon. So everything will be covered in detail. Okay. Captive portal will be discussed. Then I will configure DOS protection policies as well. Pre-net IP and post-net zone. If everything is good, right? Then your packet go and it will basically do the lookup for security policies. Security policy lookup will be done. Uses the pre-net IPs, post-net zone, application set to any, URL category set to any for the match criteria, and it will skip any rule which with action not set to allow if the application or URL category causes the match. Okay, so it will do the lookup, but here it is doing the lookup on the basis of layer 3 and layer 4 information only. It is bypassing your URL category check, and also it is bypassing your application. Generally application set to any and URL category also set to any for the rule match criteria. It will skip any rules with action not set to allow if the application or URL category causes the match. If no configure rules match, then default rules interzone deny or the intrazone allow with the match. Okay. Rule match. If action is deny, then it will discard the packet right away. And when it will discard the packet, now it will generate the log as well. It will generate the log as well. And if rule match and that rule is allowing the traffic, now if it is allowed, then it will create and install the session into the session table. It will basically add two flows now, client to server flow and server to client flow, where it will store the information source IP, source port, destination IP, destination port, layer 3 protocol, and source zone. Same for the reverse traffic, client to server and server to client. S to C, which is server to client, C to S, which is client to server. Both flows it will install into the flow table. After that, we'll go for the tunnel inspection policies, which is a TCI policy based on the source and destination zone, source and destination address and the users. It will try to check for the protocol GRE, GTPU, IPsec non-encryption VXLAN. If no, max tunnel reached. If yes, generally it will check for the maximum 4 level. So generally, let's suppose if there is an encapsulation happened till 4 level, it will check. Otherwise, it will skip. And what it will do, it will go here directly. It will install the session now. Follow state in the session table, opening or active or discard. It will reset the timeouts, and your packet go into the first path, which is security processing. Okay, so that's how your packet processing done by the Palo Alto Firewall. Now in fast path, it will do the processing. From fast path, it will go into the app engine for app ID. Multiple checks, it will perform into the app ID, right? Then your content ID, multiple checks, it will perform into the content ID. And after that, it will go into the forwarding stage and it will transmit that particular packet. Okay, I'm not covering here the full packet flow, guys, because as I mentioned, it's a 3 hours of session. And even though here also I have to cover lots of stuff in the ingress stage, because there is no only those errors, there is a multiple types of header errors we are having. And generally in your live classes, I will cover everything in detail. Okay, now one more time, guys, if you will go through with the old packet flow, you will not find much information, very simple stuff. Okay, just give me a second. Now let me tell you one more time. So guys, this particular batch, I'm starting from 8th of November. Time is 9 a.m. to 1 p.m. IST. First, we will cover complete your Palo Alto Firewall. Once Palo Alto Firewall will cover, we will start the F5 LTM. Now, Palo Alto Firewall will take 9 to 10 beacons. F5 will take 6 to 7 beacons. Fees for this entire training is 12,000. For Palo Alto with F5, if you are only interested for Palo Alto, then 7K. If you are only interested for F5 load balancer, then also 7K. Those are the contact number. This first number belongs to me, so you can reach out to me directly. Second number is for Bidit sir, and the third one for Muskan ma'am. So you can reach out to us if you are really interested for this training. We have a WhatsApp as well on those numbers, so you can, if you want like course content or you want our recording of that particular session, you can also reach out to us. We will help you. Again, this is our learning portal where basically all the recorded sessions will be provided. And if you want to purchase our pre-recorded sessions, you can able to purchase from here. This is the YouTube channel. This YouTube channel belongs to me. So you will get lots of videos on this YouTube channel on Palo Alto Firewall, AWS, Panorama, Palo Alto Advanced Level Troubleshooting, SD-WAN, multiple videos are there. We have a one more YouTube channel with the name of Skilled Inspirational Academy. Here you will get the videos on F5, LTM, GTM, ASM, Azure, Wireshark. So multiple videos are there. You can also go through here. Okay, guys, thank you very much for joining this particular demo. Let me stop the recording now.